Hello everyone. This is in continuation to hypothesis testing problems. The next problem is a management professor has given careful thought to the design of the examinations. For him to be reasonably certain that an exam does a good job of distinguishing the differences in achievement shown by the students, the standard deviation of scores on the examination cannot be too small. On the other here, standard deviation cannot be small. On the other hand, if the standard deviation is large, if the standard deviation is too large, there will tend to be a lot of very low scores, which is bad for the student morale. Experience has led the professor to believe that the standard deviation of about 13 points on a 100-point exam indicates that the exam does a good job of balancing these two objectives. So the objectives is neither the standard deviation should be too small nor it should be too large. That is the objective. Means he has to focus on lesser side of 13 points also, greater side of 13 points also. The professor just gave an examination to his class of 31 freshmen and sophomores. The mean score was 72.7 and the sample standard deviation was 15.9. Does this exam meet his goodness criterion at level of significance alpha is 10%, 0.1. So whatever we had now captured, we'll put it in terms of notations in the next slide. See, the given problem is concerned with the test for single population variance. Why we are saying variance? Because here they gave you standard deviation. Square of standard deviation is nothing but variance, right? Since they are asking about testing whether sigma, that is standard deviation, population standard deviation is 13 or not. Hence, we will use a Z test. Sorry, I'm sorry. So hence, we will use a chi-square test. The relevant test statistic will be chi-square. Calculated value is chi-square cal, which is n minus 1 times s square divided by sigma square, where s square is the sample variance and sigma square is the population variance. N is given in the question as 31 freshmen and sophomores, means 31 is the sample size. So 31 minus 1 times S is given as sample standard deviation is given as 15.9. This is our S value and this is our alpha and this 31 is our N value and this is our sigma value. That is sigma is 13. Right. So we substitute those values 15.9 the square, 13 square is 169. We evaluate this to get this 44.878. Okay, that is the calculated chi-square value. Null hypothesis. Since the question itself has given sigma equal to 13, so sigma square is 169. And since the professor is going to focus on both not too small, not too large, it becomes a two-tailed test. So sigma square is not equal to 169. So that all these things are already used in the formula to get this 44.878. Now, under this test, when do we accept the null hypothesis? For a two-tailed test, H naught will be accepted if the tabulated value of chi-square at 1 minus alpha by 2 level of significance is less than or equal to your calculated value of chi-square and it is less than or equal to chi-square table value. So that the calculated value should be less than or equal to table value of chi-square at alpha by 2 level of significance. In this question, the alpha is given as 10% or zero point 0.1. So your chi-square tabulated value at 1 minus alpha by 2 becomes alpha, you substitute 0.1. So 0.1 by 2 becomes 0.05. So 1 minus 0.05 becomes 0.95. This table value for n minus 1 degrees of freedom. For n minus 1 degrees of freedom, that means for 30 degrees of freedom. we'll be checking it from the table. And again, for alpha by 2, that means for 0.05 level of significance level, for all the for the same degrees of freedom, that is 30 degrees of freedom. This is for again for 30 degrees of freedom. We check the table value and we get this. And we need to check whether our calculated value, which is 44.878, whether it lies between these two. If it lies between these two, we can accept H naught. Otherwise, we will be rejecting H naught. So here it is not lying between these two. So we reject H naught, which means we are accepting the alternative hypothesis. That's the solution for this particular question. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.